Alright, starting Unit 3, Symmetry and Polygon. So our notes for 3.1, Symmetry and Polygon. So, a polygon is a plane figure formed, it's a plane figured formed from 3 or more segments such that each segment intersects exactly 2 other segments, one at each endpoint, and no 2 segments with a common endpoint are collinear. Now you know what polygons are. The plane figured means it's in a plane. They intersect exactly 2 other segments. Well, if here's a segment, this segment number 1, intersects segment number 2 and segment number 3. So it intersects those 2 segments, and at each endpoint. So it intersects them at each endpoint, and they're all collinear. So the collinear, all the points are on the same line. So all these points are on the same line. So they're straight lines. Alright? The segments, these are called the sides. So we have side 1, 2, 3, and side 4 of the polygon. And the common endpoint, these are called the vertices. So we have all of our common endpoints where they intersect. These are the vertices of the polygon. So we have these 4 vertices here. And that's how we make up a polygon. The plane figure, it's on a plane, intersects exactly 2 other lines. Okay? So line 1 intersects line 2 and line 3, and they're all collinear. All the points are collinear, meaning they all lie on a straight line. Now, we have lots of different types. You know that if the figure has 3 sides, it's called a triangle. And we know that if this figure has 4 sides, it's called a quadrilateral. It's not a square, it's not a rectangle, it's called a quadrilateral. Could be a square or a rectangle, but it's called a quadrilateral. 5 sides is a pentagon. 6 sides, hexagon. 7 sides, heptagon. 8 sides, octagon. Now you should know all those 8 ones. 9, nonagon. 10, decagon. 11, this is a hard one, the old 11agon. 12, well, this is your dodecagon. 13, just a 13agon. And n sides means it's going to be an n-gon. So you're going to need to know the classification of all your polygons. So you should know, the first 8 you should know coming in, and then just familiarize 9, 10, 11, 12, 13, and the n. And equiangular polygons, they have all angles. All angles are congruent. So all their angles are congruent. An equilateral polygon, all the sides are congruent. And then regular polygons, they have both, they're both equiangular and equilateral. That means all their sides and all their angles are the same. So all their sides and all the angles are the same, and you get regular polygons. The center of a polygon it's the point that is equidistant from all vertices of the polygon. So the center, it's equidistant from all of the vertices. So every vertice, it's the same distance to get to the center. And the central angle of a polygon, the central angle, it's an angle whose vertex is the center of the polygon and whose sides pass through two consecutive vertices. Sounds a lot, sounds confusing, but the central angle, it has the vertex, which is the center point, and then it passes through two consecutive vertices. So we make up that angle. We also have one over here, it passes through two consecutive vertices. So there's actually going to be 1, 2, 3, 4, 5. It's a pentagon, 5 sides. We have 5 central angles. Then we get to reflectional symmetry. A figure has reflectional symmetry if and only if its reflected image across a line coincides exactly with the pre-image. And then this line is called your axis of symmetry. Okay, so we have some examples here. So the reflected part, if you flip this and fold it, it's going to match exactly. They will match exactly. So that's your axis of symmetry. And then you can draw all possible axes of symmetry here for these shapes. Well, if we look at this first one, we go right down the middle. We flip that over, and if I drew my line good, it would make it correct. Now, we can also go from here right through there. And we can go from this one right through that one. And then from this one right through there. And then this last one goes right through there. So I drew 1, 2, 3, 4, 5 different lines. So for the next shape, we can draw a line right down the middle. If we flip it, it'll fold over onto itself. Now if you cut it in half, it's not going to match up to itself. With the oval, well, we can go right down the middle, or we can go right over that way. And then we get to this other shape. Now, if you try to cut it in the middle, that side's going to flip over and not make anything. If you try to cut it over here, once again, we don't have any axis of symmetry. If we try to cut it right in here, and then you can draw the next 3 lines of symmetry to complete these. So draw them. If you have any questions, we'll go over it in class tomorrow. Triangles and symmetry. Well, 3 congruent sides. A triangle that has 3 congruent sides is equilateral. It's an equilateral triangle. Has 3 congruent sides. The number of axes of symmetry, it's 3. From each of the 3 axes of symmetry. We have an isosceles triangle, has 2 congruent sides, so this side is congruent to this side. This has 1 axis of symmetry. And then the last one is scalene. There's no congruent sides, and this has 0 axis of symmetry. A triangle symmetry conjecture. An axis of symmetry in a triangle is the perpendicular bisector of the sides of the side that intersects and passes through the vertex of the angle opposite that side. So perpendicular bisector and passes through the vertex. Perpendicular bisector passes through the vertex. And then we get to rotational symmetry. A figure has rotational symmetry if and only if it has at least one rotation image, not counting the rotation image of 0 degrees or multiples of 360 degrees that coincide with the pre-image. That means I could take this flower and rotate it. So I can rotate it here. So if I turn my flower, everything is going to map onto itself. So this actually has 1, 2, 3, 4, 5-fold. You can rotate this figure 5 times, where each petal is going to match up with the previous one. So it has 5-fold rotational symmetry. And the central angle of a regular polygon, it's given by this formula. Well, 360 divided by the number of sides. So if we have a polygon, any polygon that's regular, this isn't going to be a regular polygon. So we'll just go back to this example here. So when we look at this, there's 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5 sides, 5 angles. And if we think about this, this forms a circle. So a circle around it is 360. So we can divide that 360 by 5. So each angle will be 360 divided by 5 degrees. So that is how you find the central angle of a regular polygon. You take 360 divided by the number of sides there are. And that was 3.1 symmetry in polygons.